Hey guys, today we are gonna solve the paper 4 uh, which held on this Sunday, and on this test we have few topics: EMI, AC, and BAVE optics plus BAVE. So most of the questions are from JMain actually, so you can get solution from Google as well. But we're gonna solve in latex. So if you are interested, you can join. So let's get started from problem number 1. I think it's pretty easy one, EMI, which is based on the Faraday law. As you can see, there is a loop which is moving with velocity v naught inside a manifold. Manifold is into the paper, and dimension of this loop is given, which is 20 centimeter as the side length, and resistance of the loop is also given, which is 1 ohm. The right arm of the loop is informed is 5 Tesla. Field is perpendicular as everything describing here. The loop is connected to a network of resistor, each of resistor 4 ohm. What should be the value of velocity so that the steady current 2 ampere flows in the loop? Yes, so we are going to find firstly the total resistance, the flux, and then we can just divide the EMF by finding using the Faraday law dphi by dt minus dphi by dt actually, and we will have the equation for the velocity with respect to the current. So yes, let's get started. So first thing we have to find out, so from where we should start? Yes, so let's start with the area. Area will be, let's delete all this, and firstly add some intertext. Yes, so we will have to find the area as a function of velocity. So we can find out directly flux. So flux through the loop is given by, yes, it is right actually, B into area. That's correct. We should add B dot A, so vector V, and then dot product. So that will be much better solution. So B dot A is the flux, and then area will be along the same, so BA, and let's put the value. Or we can put at the end of the equation here, that is meter. So EMF induced in the loop is given by minus dphi by dt is correct, and I think area is gonna we should consider side length as well, but let's move on from here. So let's modify this part, because area is changing, and length, and we can say we not, let's run it first, then we can modify later on. So as you can see, EMF is minus dphi by dt, and we have the value minus V into L V naught. For the magnitude, we can remove the minus sign, so it will be simply B L V naught, or BV L simply. Now move on to the resistor part. var epsilon. Let's run it. What is trying to suggest the copilot? Yes, it's okay. And yes, resistance for. So now we have to find out the resistance for the circuit. Now we have to find the total resistance of the circuit. So as you can see, resistor, firstly all the resistors are connected outside the circuit is 4 ohm, and 2 of them is in series and then after the parallel. And as you can see in the program, resistance of the wire is also given, which is 1 ohm. That means कि resistance across the loop will be in series, and then with respect to whole circuit it is connected in parallel. So 4m, I think it's a little weird how we can calculate this resistance. So 4 plus 4 is not actually right. Let's run it first and then we can change it later. So as you can see, copilot is suggesting a little weird here. According to the circuit, we will have the total resistance, which will be it's like 4 plus 4 8, and then after these two are in parallel. That means again 4, and then 4 ohm resistor will again be in parallel with respect to the main circuit. So let's find out. R gonna is equals to let's apply with dfrac. So 1 upon R, and then we can say dfrac 1 upon 8 plus dfrac 1 upon 8, and then again dfrac 1 upon 4, and now we will have not 1 upon 4, 1 upon 2 actually. R is equals to 2 ohm. So yeah, we have the resistance here, 2 ohm, and then we can find the current. Mm-hmm. 2 times 10 power, what is this? Yes, 2 milliampere is given. Yes, 5 times 10 power minus 1. Why it's giving minus 1? Let's run it and then we can see what happens here. So let's run this part. So as you can see, current is 2 milliampere. That's okay. V is given. L is 2 into 2 minus 4. So this part is extra, I think, 10 power minus 1. So yeah, copilot sometimes gives you the bad answer. So this is okay. Then velocity, yeah, resistance. And now we have to find the velocity. So yeah, it's fine. I think 1 centimeter per second is the correct answer, as you can see from the option as well. Actually, sometimes we have to verify this part because Copilot is not very accurate in terms of mathematical calculation. So let's check it out. So for that, I think it's not right, or is it? I don't know exactly. Or is it? Let's calculate in the terminal. Sorry, Spotlight. So divide by 5 times 200. So 0.04. It does not seem right, man. Here can manipulate 0, so that's okay. But somehow it seems right, but it is not. It must be due to the resistance, because in resistance we used 1/4, which is right, man. Why it's not right? 4 plus 4 is 8, yes. Seems right to me. I don't think in any way it is wrong. Let me calculate on the paper, because on the paper it is much easier to think. So current is 2 into 10 to the minus 3 milliampere. 5 is the Tesla. 20 centimeter, that means we have to 2 minus 2 V0 upon 2. V0 will be 2 into 10 to the minus 3 upon 5 into 20 into 10 to the minus 2. That means 1/5 into 10 to the power minus 2, and 1/5 is how much? 0.2. Sorry, 1/5, that means 0.2. 0.2 centimeter per second, and that does not seem right to me. Where we are doing wrong. Oh, it is weird. How should I proceed? Am I doing it right or not? I confused a little bit. But how Copilot suggesting? I think Copilot just knows the answer from the option, and that is why it finally solving as 1 centimeter per second. It is interesting actually. Just see Copilot doing this little mistakes. Let me see this on some reference. I think this is from JMain. That means somewhere this program has to be on the internet. So let's say EMI. Where is EMI? Yes, it's required maximum. And I saw this question somewhere on the Google, and this question is from JMain actually. Yeah, this is the question actually. So yeah, we did find 0.2 upon 5 equivalent resistance is 5, and how it is 5. So resistance will be 5. Actually, I don't believe. Yeah, somewhere this question is misleading actually. A square loop of side 20 centimeter and resistance 1 is moved towards the right. That means the total resistance of the loop is 1 ohm, not each side length of 1 ohm, and which is actually misleading in terms of language. So we have to correct this part. So firstly we can say circuit. Let's say R for the circuit. Let me remove this whole thing, and then we can proceed from there. Into text we have to add another line for the clarity here. So let's assume RC for the resistance of the circuit, and RL for the resistance of the loop here, and then we can total resistance of the, and one more line here we have to explain how these are connected actually. So you can see as you can see in the figure, circuit is divided into part in the figure. Two part, two resistors are in series with this two resistors are in parallel, sorry in two parts, two resistors are in parallel and the other two are in series, which is misleading. Firstly, grouping, as you can see in the figure, the circuit is divided in two parts. Two resistors are connected series with the loop, two resistors in parallel. No, this is not okay. Two resistors, grouping of two resistors. We can say group of two resistors. Group of two resistors are in series, and then in parallel with the other two, and then in parallel with other group. Other group and this whole network and this whole network of resistors are in series with the loop. Yes, this is right. So let's run it first and then we can modify. So now we can proceed. Interchange resistance circuit is given by let's say r is equals to r1 plus r sorry rc plus r loop, yes, and then we can no r is equal rc which is dfrac 1 upon dfrac 1 upon 8 plus dfrac 1 upon 8. So this is how these all are connected, and then RL which is 1. So yeah, how it is calculating, which is not okay, I think. Let run it first. Have to be patient actually. In rest you will do nothing, I guess. So this whole thing will become 4, and then resistance will be 5. So yeah, this is right. So resistance 5 ohm. Now we can now current level is given by us. Let's put the modulus, and this will describe the let's remove this as well. Let's run it, then see what it is getting. Just imagine a few seconds ago it was suggesting 1 centimeter per second without doing the actual calculation, and as you can see how this can be dangerous in some situations. I think still sorry we can put the value of V5, that will be okay, I think. Yeah, 1 centimeter per second, so it seems right now. Wow, but it is quite long, but no problem. We can proceed to the problem number 2. So yeah, language is a little bit misleading. The whole circuit have the resistance 1M, not the single wire. That means this is saying about the loop. It actually English problem, I guess. So yeah, let's move on to problem number 2. Tasks, man. Solution. And right arrow thing. Right arrow, right. And in this problem we have the amplitude given for the two coherent wave, A1 upon A2 is equals to 1 upon 3. The ratio of the maximum and the minimum intensity of the fringe will be. It is quite simple, I guess, if you know the equation for the amplitude versus the intensity equation. So firstly we can add some intertext part. So as we have the relation between, as we know the intensity of the light is given by as we know that the intensity of light at maximum is given. So should I use directly equation, or we can just go from the fundamentals? Let me check, am I live or not? Open Studio, YouTube is not. Why? A smooth streaming, either YouTube is not receiving enough. needs 23,000 kbps and I have the like 2000 kbps. Let's continue, don't worry about this. I don't care about the streaming part actually. I'm more focusing on the solution part. So let's right now just leave it there. I will just zoom a little bit so that we will be able to see much more easily. And as we know the intensity of the light, as we know, we can start with we have the relation, between should of the wave I is equals to it seems right, and I1 I2 no man, actually it's right, but ratio of maximum and minimum intensity, it seems right, because we can proceed with the help of ratio, that will be much better I guess. So let's run it because I am not sure about this part. 1/3, yeah, right. 1/9 intensity. Let's run it and then see what happens. So here Imax, wow, it is giving the proper explanation for everything. Wow, let's accept this as well and see what happens. Now is the weird part. I think no, it's correct. Square root. I don't know, is it right or wrong? What we have divided is not actually right. This is not a better way. So let's use right arrow thing and then right arrow, and we can say that I1 9I1 is equals to I2, yeah, and from there we can proceed quite easily I guess. Yeah, this is much better solution. So yeah, it is not good. We have I want to begin, yes, replace I2 with 9I1, that will be much better. So I2 but 9I1 and then we can remove better, and in the same fashion we can use 9I1 and then 9I1. Let's run it and see what happens. So yeah, it is right now. So as you can see 10I1 plus yeah, it seems right I guess, but it's not right. Here we have to put a square actually. This is so as you can see in the very basic thing sometimes it is just messing thing up, and now we can get 16 divided by 4, which will be 4, and finally we got the right answer. So yeah, this is right. Let's move on to third question. So third, again start with the right arrow. By the way, if you are curious in like how this Copilot is helping. So as you can see, it is quite good at predicting the text. Not it will help you in terms of idea. Sometimes it does, but you have to guide it actually. You will have to write the fundamental equation by yourself, but sometimes it just suggests. Just say you can see in this part. Actually, let me accept this whole thing and see what happens from here. So as you can see, uh, let me read the question first. A 12-volt battery is connected to a coil of resistance 6 ohm through a switch. Drives a constant current in the circuit. The switch is opened in 1 millisecond. The induced the EMF induced across the coil is 20 volt. The induction of the coil is. So for that, you just applied the EMF equation for the coil. Yeah, it's right. Actually, it is an inductor, and as we have the EMF induced in the coil is 20 volt. 20 is equals to it's right, and as you can see, it's just messing thing up at the end. As you can see, di upon dt is 0. That is not it. Yeah, actually I am live. क्या वो बोलो बोलो नहीं नहीं बोलो बोलो नहीं नहीं जाना गेट लगा देना जोर से ओके. So this program is quite confusing as well according to language perspective. As you can see in the first statement, it's saying that there is constant current, but in the second statement, switch is open in 1 millisecond. That means opened for 1 millisecond should be like that. That means the total current is derived, but the time should also be given. Oh man, I am confused. di upon dt, what is it saying? So we can find the current here. So let me start from this part. Or let me do from the basics. Let me explain the question actually, and that way it will be much better solution. So as you can see, again it predicted the right solution, but I think you should know it is not correct, so you have to be careful. So let me explain. Switch is to open in 1 millisecond. So question is right, but language of this question is not properly. So let me explain. As we can see, there is a constant, there will be constant, there will be constant current, constant current of 12 by 6, 12 by 6. Constant current of let me say defrag 12 by 6. 12 by 6 we are doing here is we are just dividing the resistor in the potential. This is how we are gonna get the constant current, which is equals to 2 ampere. Current of 2 ampere is flowing in the circuit, and then suddenly, and then after as you can see, there will be current of in the circuit. Constant is wrong. Like current of ethanol is flowing in the circuit in that terminal only. Yes, circuit in between the interval of 0 to in between the interval of yes, within the interval of t is equals to 0 and t is equals to 1 millisecond. Yes, 1 millisecond. I don't know. Millisecond is the correct acronym I have. So let me check. Between t is equal to 0 and 1 millisecond, flick current of is flowing in the circuit once again. So, but the inductor, coil, we can say inductor in the bracket. The coil inductor will not allow the current to change instantly. So current will change in the interval of time 1 second, and hence so now we can find the average di upon dt. So let's var and dt not 2, yes, 2 ampere by 1 millisecond. Let me do one more thing. For the average, we can use delta I on delta t, and for that, yes, that is okay. Let me see what happens here. Something is not right. Let us see the terminal log output, what is the system. So yeah, millisecond is not different. I was afraid of this part. So we can just change this millisecond thing in the package, or we can just, but let me, no, for right now I'll just change it here. So millisecond is not actually a macro describe. So let me actually M stands for meter and S stands for second. So I'm using it for millisecond. In that way, it will be okay, I guess. And let me run this part first. Again, somewhere this time I don't know where it seems wrong. So yes, again here one more time we have to fix this millisecond thing. So yeah, as you can see, it seems right, and 1 millisecond, and actually current will go on decreasing. Let me read that. As we can see, there will be a current of ethanol is flowing the circuit between the interval at 0. But the coil will not allow the current to change instantly. This current will change in a time of 1 millisecond. I'm not feeling good about this explanation actually. Yeah, it seems right, but I'm not okay. No, it seems right, um, but I'm not okay. Current will decrease with the time. Oh yeah, now I get the proper solution. So as you can see, there is a current is flowing in the circuit between. No. This is wrong. Uh, there will be a constant current. So initial solution was right actually. Constant current of flowing in the circuit. And let me remove. This one. As soon as a circuit after circuit after we can say now after opening the socket not opening the switch. Now after opening the switch, current will switch after t is equals to, that was simply 1 millisecond. Will we find 1 millisecond? After 1 millisecond, current will one millisecond. Current will drop to zero. So there is change in current. So the change in current there is change in current. There is change in current in some time interval. And hence they will be induced. Yeah, now this is fine. So delta I, which is minus 2 ampere, and the time minus, so minus will get reduced to 0, and now it is correct solution. So equation will not change here, but the idea behind this will change. So as we can see, there will be a constant current of 2 ampere is flowing in the circuit. Now after opening the switch, after 1 millisecond, current will drop to 0. So there is a change in current in some time interval, and hence there will be an if induced in the circuit. It is much better solution when compared to previous. So let's move on to question number 4. Some of you were thinking why you are taking that long in solving problems. Like you just solved 3 problems in about half an hour, more than 45 minutes. So it doesn't matter. I'm just focusing on the solution part, or also the latex part. So yeah, it takes time actually. It's not like you are solving on the paper, just writing for the sake of one equation, and every time you will get right. That doesn't work in this form. So yeah, copolarity is suggesting something, and let me accept this solution and see what happens there. So velocity of the wave is, yes, it's right. The tension in both the string, yeah, absolutely right. And as the mass per unit length 2 is more than, wow, It is suggesting very good solution actually. Tension, yeah, it's right. It's perfectly right. There is no problem in this solution. So we can accept this and move on to problem number 5. And in problem number 5, I think an EMF of 0.08 volt is induced in the metal rod of length 10 cm held normal to the uniform magnetic field when moves with the velocity. I think it is from the motional EMF. When a conductor moves in a magnetic field, it acts like a polarity of charge, or you can say after some time it will create a polarity, and that will behave as a source of potential. So EMF is BVL, yes, absolutely right, 0.10 centimeter, which I don't feel okay about, because it is not converting in terms of SI unit. So 10, what is L? Yeah, it is messing thing up a little bit here. So 10 times 0.4 is the magnetic field, right? 10 times 10 to the power minus 2, and minus 2 will be like this. Actually we are doing here to convert this section into meter and times V. Let's continue with this. 10 times 0.8 divided by 0.4, yeah, absolutely right. So this is 1 naught L, and from there I guess we'll get 2 meter per second. Yeah, it's absolutely right. Or is it? I don't know. 10 will be, I don't know, man. 10, yeah, absolutely right, it's correct. So let's move on to 6th number. I'm live now.
ऐसे मौके बार बार नहीं मिलते।
नहीं जाना मुझे सच में। स्केटिंग अभी लाइक फरवरी में करेंगे ना, जनवरी में।
फरवरी में बंद होता है
और नहीं करेंगे
ऐसे वो हो जाता है।
मैं किया था कारगिल में।
कारगिल में रहता है, यहाँ पे जल्दी पिघल जाता है फरवरी में।
बाद में अभी नहीं जाने का मुझे। संडे वगैरह गेट लगा देना जोर से। So again it is suggesting some solution. Let me accept this, and then they will modify later. So you can see in 6, let me first the question. Actually most of the time I am not reading the question and just trying to solve. This is weird. So in this problem the induced EMF can be produced in a coil by A. By A, sorry, I put the coil by A, moving the coil with uniform velocity. I think there is a mistake in the language. By, oh sorry, we didn't put line break actually in the question. So yeah, oh man, what I did in the question. So this is yeah, this seems right now. Moving the coil with the uniform speed inside the magnetic field. Yeah, it's right. But only the induced EMF can be produced in a coil by. Oh, let me continue reading. So option B is, so not option B, point B is like moving the coil with non-uniform speed inside the magnetic field. Option C, rotating the coil magnetic field, the changing the area of the coil. Yes. So option A is wrong actually. Suppose you move a coil in a magnetic field, and if this coil is already in the magnetic field, then there will be no change in the magnetic flux, and hence EMF won't be induced in the coil A. And in the B condition, this is saying with the non-uniforms. It doesn't matter if you move with uniform or non-uniform flux would be changed by moving, but again it is not happening. So option point B is also wrong. Point C is saying rotating. Yeah, rotating is important because with the help of rotation, theta is changing, and hence the flux is defined at B dot ds. That means angle between magnetic field and the area vector is keeps changing, and hence the flux, that means EMF will get induced. And this is how the motor or turbine works. And D point is like changing the area of, yes, of course, if you change the area, that means if you are changing the flux, that means EMF will get induced. So option C and D are right, but let me see the explanation of Copilot. Oh yeah, it seems right. With the magnetic area is the coil theta. Yes, right. As we can see that option A and C, the area is not. This is right. Messing thing up. As you can see, A and B we have to modify. Option A and B, the area C point A we should write, but let me continue this. So let's run this part and see. So as you can see, option A and B, the area of the coil is not changing with time, so there will be no EMF, and in option B, area of the coil is changing. So we have to actually it is right, but we are interpreting of this is not option. In point C we should, or we should say a statement C. Statement. This is much correct way to explain, and let me fix this statement. In the statement A and B, the area not changing here, and in the C, the area of the changing. Oh, area is not changing, the angle. A-N-G-L-E. Angle, not angle. Angle is changing with time, so there will be EMF induced, yes. In statement D, statement D, the area is changing, so there will be induced EMF, yes. So let's run it first. So finally we can write that arrow takes C and D only. So yeah, 6 is done. Let's move on to problem number 7. Begin solution, then write everything. In this problem, let me first a square loop of area 25 cm square has a resistance of 10 ohm. A loop is placed in magnetic field, magnitude of 40 Tesla. The plane of the loop is perpendicular to the magnetic field, right? The work done in pulling the loop out of the magnetic field slowly and uniformly in 1 second will be. So again, Copilot is suggesting something. Let's accept, which is quite good, I think, but I don't know. let me read this solution part. So EMF induced in the loop is given by, yes, it's right, flux is the magnetic flux here. Magnetic flux is given by, absolutely right, absolutely right. As we can see the statement, the area of is not changing with time, so we know EMF. Oh, and why saying that? Field F dot S. So from where it is getting force? VIL. Yeah, it's right, it's right. Wow, can you imagine like how fast it's solved, and it is right actually. Mm, you can say flux is, but in the statement it is described wrong. Mm, mm, by pulling, one second, let me grasp this first. Actually it is describing right, but the statement in which it is let me see. So as you can see, second statement is purely wrong. As you can see, as we can see in the statement, the area of the loop is not changing, which is not correct. The loop is placed in the uniform magnetic field, magnitude of 40. The plane will be perpendicular to this slowly bugged in plane. That means like in the question one, this loop is getting pulled out, and in the process of pulling out, we have to find out the Bogdan how much work can be done to pull out this whole thing. So let me explain you the part. So as soon as this loop will start to move outside the field, this circuit will still be carrying a current due to the change in flux, because as soon as we start to move this part towards the left, the area will keeps changing, and hence the flux, and hence the EMF will keeps changing in the circuit, and according to that a current will flow in this loop. And as you know already, a current carrying wire experience a magnetic force in any magnetic field, and this is how this loop will experience a force towards right, and we have to do the same towards the left as well. We have to apply a force towards left, and that force will drag this loop towards left, and hence that force will do some work done. So in that scenario, it is not describing in a proper manner, but calculation wise it is doing right. So let's fix this part. Let me get something fast. So we don't have to describe everything about the flux in every problem. So we can remove this flux part, a description of the flux, and we can describe the mechanics behind the force. That will be a better solution, I guess. So let's delete all this part. I think we also have deleted the below part. Actually, calculation is not, but let me see after giving some information what Copilot will suggest. So into text, and firstly we have to describe the scenario. Or should I draw a diagram or not? No, diagram will take time, so I'm not going to or should I? Let me create a diagram that will be better to eyes, I guess. So we will start with the center, and then we can ingest text picture inside the center, and we can copy the field and everything from the first diagram. So let's copy this field part and we should remove this whole section, resistor and current thing, and this part as well. Let me run this first and see how it is plotting the diagram. So it is much bigger, so let me decrease in the y-axis. We can change from -3 to -2 and to -1, and this will go from -2 to 2, and in the x direction it doesn't matter because it is not occupying much space. And now we can draw a loop here. What we have to do for a loop? We are drawing. Oh man, I'm confused right now. Okay guys, wait few minutes. I'm finishing something. Concurrent for 0, total is 4. That means no one is watching, and that's good for me. Wow, YouTube is warning pretty much every other 15 minutes. Two likes. Who liked my video? Sorry, who liked my stream? Who is liking this stream, man? I don't think anyone watched. But okay, we will continue. Few minutes. Yeah. Where we were? I lost the question. Yeah. So let's continue. So here we're gonna describe D, which is the side length actually. So let's describe the thread length with A. And now we can make a loop. So draw is, I think, better command for. So we can start from not minus A. We should start from, yeah, x will be minus 2 times A, and then y will be minus A, and then from there we can use relative coordinate 1 comma 0, then again we can use relative coordinate 0 comma 1, and then again relative coordinate we can use minus 2 times A. So it is a square, na? Let's continue doing this. Let's run it and see what it is drawing. So yeah, it is loop actually, but we have to increase the size of the loop because it is not okay. So 2 times A, and we will have to do minus 3 because x coordinate is and then at last we can use cycle. Cycle just connects the point from the beginning. Oh, it is wrong. Minus 3. So we are doing right. Oh, but here we have to move 2 units, right? So as you can see, this is a square, and this square thing will experience a force. Now we have to apply a force. Let's not use draw this time. I'm going to use TZ line. TZ line is pretty better for a relative coordinate thing. So from where we are going to move. So 0 comma 0 towards left, and we have to apply a force. Minus 1 comma 0. Not 0 comma 0, sorry, minus 3 is okay. From minus 3 to, yeah, so on the loop we are applying a force, and this force will, and let's copy this whole thing and put one more time minus 1 to 1, and towards this time it's right, and it's F magnetic. Yes. And let's describe this section here. So as soon as we pull the loop out of the magnetic force will acting on the loop. No, it is not right completely. So magnetic field, the flux will change, and hence there will be EMF induced the loop, and this EMF will drive the current. Will produce a current. Look, this one is force. Current, and so now it's right. As you can see, as soon as we pull the loop out of the magnetic field, the flux will change, and hence there will be an EMF in the circle. This will produce a current in the loop. This current will produce a magnetic force or force. It is not actually right from here. Produce a magnetic force on the right pair. Pose the motion on the wire. Hence, we have to apply an equal and opposite force on the loop to pull it out of the magnetic field cells. This is the correct perfect example. And now we have to describe the equation. So force on the magnetic field wire, yes, right, when the charge is current. So yeah, this is the right explanation. As you can see, the current will induced according to the EMF, and then magnetic force will be like BIL. So L will be accordingly, and Bogdan is force magnetic into displacement. Yes, so this is right. As well as the velocity 1 meter per second. Velocity is given, right? Velocity is given, but I don't think velocity is right. So let me complete this part. 40 Tesla square, yeah, it's right, and then LQ. So L is 25, that means 5 centimeter. So we have to apply here is 5 times 10 to the power minus 3, because minus 2, because it is in centimeter. And then velocity, so velocity will be, I think one more equation we can replace velocity as sorry, from here it is wrong. If we say we have to put T here, into T, and 5 times 10 to the power minus 2, and whole thing we have to do 3, yes, and then we can remove this part, and from there we can times 1. So yeah, this is right. We can put the velocity. Sorry. This will raise to the power 4 because one more L will come because of the velocity part. So now this will be like 5. How it is like b square. Let me calculate this part in the spotlight. 40 square, not 10 square, 40 square, and this will get multiplied by 5 to the power 4. So 5 to the power 4. Also this will whole thing get multiplied by 10 to the power minus 8, 10 to the power minus 8, and whole thing will get multiplied by, and then we will divide. Yes, so actually it is right, 1 into 2 minus 3 joule will be the work done. So calculation is right here. Yeah, one more step we can proceed, that will describe in a much better form. Let's describe defrac. So 40 square will be 1600 times 5 square 25, 25 square will be 625, 625 times 10 to the power 8, 10 to the power minus 8 actually, and then denominator will be like 10. So wait, convert. Yeah, here. So as you can see, after multiplying, yeah, we can get close to that. Let me add one more line, that will be better, I guess. So it is not suggesting anything. We have to do manually. Defrac. Let me 1600 into 625, which is 10 to the power 6, which is 10 to the power 6 times 10 to the power minus 8 and divided by 10. So now it's correct. Let me add line break here. So yeah, this is it. As you can see, the solution is quite long, but if you are just solving an exam or anything, it won't take that much time, because you do not have to do all these thing in a systematic way. Just you can directly find out the manifolds, and then you can integrate or just put everything accordingly. Let's move on to question number 8. 7 is done here. So question number 8, the figure shows the Young's double slit experiment setup. It is observed when a thin transparent sheet of thickness T and refractive index mu is put in front of one of the slits, the central maximum gets shifted. There was a spelling mistake there, by a distance equal to n fringe width. N fringe width. If the wavelength level, then T will be. I don't think n is described properly, but yeah, I can see a slit is placed. So now we can we have to find the delta x, which is the path difference, and then from there we can find the thickness. So let me copy this diagram, because we will need this diagram here. And we can start alignment. So in the diagram we also have to describe about the delta L. So first, actually nothing is named here in the coordinate format. This is quite tedious, man. Let me describe first a few coordinates. This will solve. So So first coordinate will be the S1, so it will be at minus 0.45, which is, let's say, capital S1, and let's complete this. So S1 is the source of, or we can say, position of the slit, and from there we can draw a line S1 to it's not actually right, but let me see where it is drawing. So S1, this is wrong actually, let's draw manually. Create line, we do not have to do this. I think S1 to 4,1. So yeah, 4,1, and one more thing we can describe here is 1 point as the, so S1 is like that, and then we can join this part 4,1 from S2, and one interesting thing we have to do is to place a slab of thickness T in the path of S1 or S2, it doesn't matter actually. So let's place a draw a rectangle, draw like a rectangle. So from where we're gonna draw, so let's say S1 rectangle, and but from there we can move this part. So thickness is much more, so we can just say, and S1 is 0, that means we can plot 0.5 comma minus 0.5. So yeah, as you can see, there is a slit placed in between the path, and now we have to find the path difference. So let me see one of the slits, yes, and its refractive index is also given me. Now we have to do some interesting thing here. Enter text. Firstly, after placing the transparent in front of the slits, a path difference between given by not this is not the correct, not the slits. Actually d sin theta d sin theta is the original path difference. I don't remember exactly d sin theta or d. Let me check this expression from some book here. This is wave optics, right? I don't know where. Yes, this is wave optics. So let me see after placing a fringe, how much path is getting changed. So path difference without the path difference without placing any slit is actually by d upon d, and after placing mu minus 1 times this, it will just shift this forward, and now the fringe with it, sorry, the path difference will get added to it, and then after we can find out the position. So it's quite tedious. And then net part of naturalization. So we have to do a few drawings here, and for drawing we can define another coordinate which is p. P, and we can just replace this part with a p. And one more thing we have to do is remove this screen part. Don't need screen, or we need, so let's keep it for right now, and let's run it, and we can indicate one more thing. Sorry, we have to put p as well towards right, and now we can note out tz line, from where we should drop tz line. I think 0,4. From there we have to p, and there we can shift 1,0 towards right. Midway right. And one more thing we have to do is, so this is perfect. Oh man, I did one horrendous thing. 4,0. So now it's right. 4,0. Yeah. So as you can see, yeah, it's right. 4,0. From there we can indicate the point y. Now we can find out the delta x. So delta x will be, let me point out the source as well, that will be better in terms of indication. Source 1 towards left, yes, and here as well, but Copilot is not suggesting. These are the things Copilot should improve actually. So, oh man, where did I place this one? Towards left, right? I don't think. How this happening? Oh. If we put node in the coordinate, we have to just shift this part towards right. This is how. And now it will be perfect. Yes, S1, S2. And now path difference will be given by, it's like S1P minus S2P. And from there we can, S1P will again be shifted by the amount. So let's not do that thing. So let me see again the reference here. So S2P minus S1P and S1P minus S2, so that will be so yeah, let me mu minus 1 into T. So first thing we have to do is S1 will get shifted due to the so we have to add here intertext and say S1 P will get shifted by distance of T by shifted by up mu minus 1 times T. That means the so now delta x, so S1P minus mu minus T minus S2P and now we can group actually S1 P minus 2P, yes, and then we can let's keep that way and we can shift here diffrac ay upon D, which is capital D. So let's see here for again reference yd upon D. D is so yd let me put A instead of D. So yeah, now it's okay, and we can modify it from here. So let me see one more time reference. So yeah, that will be okay for nth order to be maximum and lambda, and we can find out quite well. So let's move on to question. So in the figure it is observed that when a thin transparent sheet of thickness 3 refracted mu is put in front of the central maximum gets shifted by a distance. So central maxima used T will be thickness by central maxima. For central maxima we can use n lambda and n will be 0, and now we can say intertext new central maxima gets shifted by n fringe width n times new central maxima is at by is equals to n times width of the fringe, right, for maxima. So for the central max, so delta x is equals to L lambda, or for maxima you can use, it doesn't matter, but pi will get shifted accordingly. And for central maxima, simply for central maxima it should be 0, yes, and this would be 0, yes. Let me continue this part, yes. So this will be right, but I don't think, let me find out what is the width of the fringe. So fringe width, where is fringe width? Where is fringe width? Path. Just fringe width is lambda divided fringe width. Omega, we can say. Omega. And omega, and we can use pi divided, yes. No man, you are doing right. No, sorry, wrong. Pi is equals to n times pi is small divided, which is the fringe. D will be capital and this D will be small. So this will be, so fringe width is like that. Actually, fringe width should not depend on the pi. Fringe width should be independent of the pi, right? Let me see. Yes, fringe width. New central maxima is at n omega, because in the initialization show by C will be okay, but I don't know what to do here. Let me calculate on the paper. After that, it will be much clear explanation. So pi d by a small d minus mu minus 1, d is equals to 0, and pi will be d by nd, yes. So t will be, no, it is not right. Let me see the solution of this problem. I think it will be from the base.